For the second part of controlling pH in soils, can you please turn with me to your theory book, page 94, and let's begin. Um, Controlling pH in soils, this part in your syllabus is actually an application part of the chapter. So we are learning how to apply what we have learned to an everyday scenario. And of course, this everyday scenario is not your everyday scenario. It is used in the agricultural industry. And agriculture industry, in the sense that the farmers plant crops, they will need an optimal pH in which they can plant and obtain the best yield for their crop. Okay, however, the soil that the farmers use may not always be at the optimal pH, meaning the best pH value possible. So what can farmers do? And the thing is also that generally soil pH, okay, generally soil pH tends to be acidic. Why acidic? Okay, why acidic? Is because when it is exposed to nature, the rain that falls on it are generally acidic. Okay, this is generally due to acid rain. And we know that the in countries where there's agriculture and also when there is industries operating, the industries and cars on the roads and all that, they will burn carbon based fuels, right? So fuels like petrol, diesel, coal, all that, they are carbon based. And carbon based fuels, when combustion is carried out, what will happen is carbon dioxide will be produced. So in places where there are a lot of fuels being burnt, the amount of carbon dioxide being produced will also be higher. So what did we just learn about the types of oxides? What type of oxide is carbon dioxide? Carbon dioxide is a non-metallic dioxide, which means that it is a type of acidic oxide. So this is why it can contribute to acid rain. When this acidic oxide is exposed, is released into the atmosphere and it dissolves in the moisture that's found in the air, okay, and it accumulates together in the rain clouds. So when it falls, it will come down as acid rain. So a prolonged exposure to acid rain will cause the soil to have a low pH, to have an acidic pH. All right. So generally, what farmers would want to do is that they will want to increase the pH to the optimal pH of their crop. And so examples like potatoes have pH of 6, cabbages have pH of 8. So in order to increase pH of soils, can we add an acid? Well, we can't add an acid, right? So that is why we'll tend to add bases. Okay, we'll tend to add bases actually. Okay, so generally here you can see that we are concerned with soil pH being too low. Okay, so how can we increase the pH? To increase the pH, farmers generally use this chemical called slick lime. What is slick lime? It is solid calcium hydroxide. If the other chemical that you are very familiar with is lime water, right? So do know that slick lime, because it is just slightly soluble, when it is dissolved in water, it actually forms the chemical lime water. So note the difference in the state symbol. What farmers use is slick lime. So why is it that they use slick lime and not chemicals like sodium hydroxide? Okay, so why slick lime? Let me write this properly. Why slick lime and not sodium hydroxide? The idea is that is really due to solubility. Okay, the main idea here is really due to solubility. Slick lime is only slightly soluble, whereas sodium hydroxide is very soluble. So for slick lime, when it is added to soil, if it is if I add the sorry, just to backtrack, the thing is the farmers are not able to determine exactly how much bases to add in. Okay, so usually what they do when they put fertilizers, which some of them may contain slick lime, is that they just put a lot of it onto the soil. And if we add in a chemical that is only slightly soluble, the excess of the slick lime that didn't react with the acids in the soil, they will just remain on the soil. Okay, they will not affect the pH of the soil at all and cause it to be too basic. However, on the other hand, if we use sodium hydroxide, because it is very soluble, it will immediately just affect the pH of the soil, not just to the optimal pH, but it will exceed the optimal pH and make it become very alkaline, very basic of about pH 13 or 14. And that is definitely not what we want. So the reason why we use a slightly soluble base like slick lime is because of its solubility. Those that didn't react, those that didn't neutralize the pH of soil will just remain as solid, and they will not affect, so will not further affect pH of soil. Okay, so that is the main reason why, and that's the most common question that students will ask as well. So please just take a look at the questions in your book. Okay, so we have already done this. Importance in controlling pH of soil, which is found here. All right, so please go back and you can pause the video to fill this in. Generally, we are concerned with soil pH becoming too low, suggest why this may occur. We have done this as well, is found over here due to acid rain, okay, or soil decomposition. Okay, because in Sec 2, when you learn about chapter 19 on scavengers and decomposers, you will learn that when feces or dead organisms are decomposed, carbon dioxide gas is also given off. Okay, so in this case, CO2 given off during decomposition. Hence, because it is an acidic oxide, it can also cause it to be acidic. Okay, next, name the common substance that's used to control the pH in soil. This is slick lime, or you can write solid calcium hydroxide. Next, why are insoluble bases or carbonates preferred over alkalis for soil pH treatment? So we discussed that just now is generally this. Okay. Insoluble bases or carbonates, like we said, they are insoluble. They will just neutralize the acid and not further dissolve to create an alkaline solution and raise the pH beyond 7. Okay, but on the other hand, alkalis will cause it to go beyond pH 7 and exceed the optimal pH of soil that the farmers would prefer. Okay, so you can pause this and write this down. And lastly, why do farmers not add fertilizers containing ammonium nitrate and slick lime to soil at the same time? This is a very common O-level question actually. For plants to grow well, they generally need nutrients containing these three elements: N, P, and K. Nitrogen, phosphorus, and potassium. Hence, in many of the fertilizers, you would notice that they will contain chemicals that contain the element nitrogen, phosphorus, or potassium inside it. Um, so this is for fertilizers, for plants to have their nutrients, right? On the other hand, sometimes farmers add slick lime. This is to, what's the purpose of this? This is to adjust, this is to adjust pH of soil. So here we have two different purposes. Okay, one is to provide plants with nutrients. The second is to adjust the pH of soil. If farmers were to add both of them at the same time, what kind of reaction would happen here? The reaction that would take place here is something that you have already learned, which is ammonium salt plus alkali. We get salt plus ammonia gas plus water. So instead of the ammonium salt, which is your ammonium nitrate in this case, instead of it trying to provide nutrient for the plants, and the alkali, in this case your slick lime, trying to adjust the pH of soil. So instead of serving its purposes, they are unable to serve its purpose, but instead they react with one another. So if you were to add these two substances at the same time, they would cancel out each other's purposes, and hence causing the reaction of salt to produce salt plus ammonia gas plus water. So you're wasting the fertilizer, you're also wasting the slick lime. Okay, so please take note that this is a very common question that's asked in O levels. Okay, the answer is not shown here, so let me just write it down for you. I'll write it below. Okay, so this is because the ammonium salt, the ammonium nitrate, and slick lime will instead react with each other to form salt, ammonia gas, and water. Hence, the ammonium, the fertilizer will not be able to provide nutrients for the crops, and the slick line will not be able to adjust the pH of soils. Okay, so please write this down. It is an important question and you must know how to explain this. Okay, and that's it. Please read the instructions later to find out what you need to complete for today's lesson.